How do you test a function that calls filepath.Abs in your Go code? I'm going to answer that question. Hi, I'm Jonathan Hall, and I was recently browsing StackOverflow when I came across this question. How do you test filepath.Abs specifically for an error in your Go code? Now, there are two general approaches, and the question actually talks about using mocks or injection to accomplish this problem, and that is one approach, but they don't want that approach. They wanted to do this without that, which makes good sense. I'll talk about that more in a moment. The second approach is to cause the function to actually generate an error legitimately, which I'll talk about. And there's actually a third approach, which is simply not to test it at all, which I'll also talk about. Of course, there is a link in the description to this original question, and as well as my answer to the question in StackOverflow. If you prefer to read that rather than watching a video on the topic, feel free. So let's talk about the pros and cons of the first approach, mocking and dependency injection. Now, mocking is generally frowned upon, especially in the Go community, but really in any language, it's used way too much in many projects. Mocking is useful for, broadly speaking, two main purposes. The first is if you want to separate components for testing. The name unit testing, of course, comes from the idea of testing a single unit of code. And if your unit of code depends on another unit, then you sometimes want to separate those out so that in case of a failure, it's obvious which unit failed. That reasoning doesn't really apply very much to the standard library in any language, honestly. We can, generally speaking, trust the standard library to be bug-free. There are, of course, exceptions. We do find bugs occasionally, but they're exceedingly rare, and they usually get fixed fairly quickly once they're discovered. So as a general testing strategy, you don't need to separate your code from the standard library for the purpose of isolating failures. The second reason to use mocking is because of complexity. Maybe it's actually too complicated. Maybe you trust the code, the second unit you depend on, but it's too complicated to configure or set up or whatever in your test. That might be a valid reason to use mocking in this case, or in similar cases, although probably not really, once we see what's involved in testing it, quote, legitimately, which we'll do in a moment. The main point, though, is that the author of the question wanted to avoid that approach, and so was looking for a second one. And I believe the second one is more appropriate in this case, which I'm going to talk about next. Now, before we look at actually writing code to do the test, which we'll do, let's try to understand what filepath.Abs does and what might cause it to fail. Let's start with the Go doc. As always, pkg.go.dev is a great place to find the documentation for the standard library and anything else. That's where I am now, and I'm going to look at the documentation for the filepath package and specifically the ABS function. So what does the function do? It returns an absolute representation of a path. So you pass in a path, which is a file name or a directory name or a combination of the two. If it is not absolute, then it tries to resolve it based on your current working directory and return an absolute path that you can use. So that's what it does. What might cause it to fail? The best way to answer this question in general is to look at the source code. And that's actually pretty easy to do with the standard library. If you're intimidated by that, please don't be. It's very simple. From the same page on pkg.go.dev, we can just hop over to the source code. And you do that by clicking on the name of the symbol, in this case, the name of the function. So we click on ABS, and we see where that is defined in source code. Now, in this case, the ABS function just calls another function called ABS that's lowercase. We can just click on that name, and it'll jump us to that definition. That one, in turn, calls Unix ABS, or at least it does on Unix systems, which is what this package is configured for. That does mean that there are other operating systems, in particular Windows, and probably others, that use a different implementation, and in those cases, they may fail in some other way, but we're going to focus on just this one because it's fairly simple. If you need to trigger specific operating system-specific errors, you'll need to do a little more digging. Let's click on Unix ABS now to see what that one does. And here we are finally to the meat of the function. Let's see what it does. There's three return statements. The first one returns if the input argument is already absolute with no error. So that's not going to trip us up. The second one looks for the current working directory, and that one might return an error. So if we experience a failure calling os.getwd, we return that error here. And the third option just joins the working directory to the argument with no error. So we don't care about that one either. So, in essence, the only one we care about when we're trying to trigger an error in our test is os.getwd. Let's see what that one does. Again, looking at the Go doc for the OS package, the getwd function, we see that it returns a rooted path name corresponding to the current directory. So how could we make getwd return an error? Now, I'm not actually going to dive into the code in this case because I already know the answer. If the current working directory doesn't exist, this will return an error. All right, so we know how getwd might fail. We know how we might be able to trigger that. Let's write a test and then see if we can make it do what we expect. For the purpose of demonstration, I'm only writing a test here, and I'm just going to test the standard library function. So I'm not actually testing my own function that calls that to keep this example as simple as possible. So this is a very simple test. All it does is it calls filepath.Abs with an argument foo, and if it does not get an error, it causes the test to fail. Let's run this test and see what happens. It fails, as expected. So what we want to do now is to find a way to make filepath.Abs trigger a failure, to trigger an error. So we know that if os.getwd is called in a directory that doesn't exist, it will cause this to generate an error. So how do we do that? Well, it's a few steps, but it's not that complicated. Let me show you. There we have it. Now the test is passing. What did I do? First, I created a temporary directory using the os.mkdirtemp function. I passed two blank arguments. The first one is the temporary directory to use, and if blank, it defaults to the default, which is usually /tmp on a Unix system. And the second one is a file name pattern. I don't care what file name pattern we use, so I just like to use the default, and it creates something useful. Next, I change into that directory that I just created. Then I delete that directory. So now my current directory is no longer valid. When I call filepath.abs, I get an error and my test passes. Are we done? Not quite. There's still a couple things to think about here. The first is that we've now changed the directory of the running process. Now, in this particular case where there's only a single test running in the process, that doesn't really matter. But if you have a large test suite and any of your other tests depend on the working directory, maybe to open config files or to write files or anything like that, they're probably going to start failing now, and it's going to be confusing. So you want to restore the original working directory after this test runs. So that's just a couple more steps. Let me show you. So now before changing into my temporary directory, I look up the existing or original working directory and store that in a variable. Then I call the t.cleanup method, which registers a cleanup function to run after the test is done, whether it passes or fails. And that cleanup function just calls os.chdir to change back to the original directory again. So now any other tests that run after this will be back in the original working directory as they expect. So that should solve the problem. There is one other thing to keep in mind, though, and that is that normally, good practice when writing tests in Go is to use that t.parallel call, which allows your test to run in parallel. However, if you do that here, you're going to run into some problems. So you don't want to do that on this type of test because this test modifies global state. So don't call t.parallel in this test or any other tests that change the working directory or environment variables and things like that, because if you have multiple tests that depend on that state running concurrently, they're going to trample on each other. You're going to end up with race conditions and broken, unstable tests. So that pretty well covers it for the legitimate way to actually cause filepath.abs to generate an error. Key points to keep in mind: the standard library is easy to read in most cases, and it's your friend. Have a look at the function you're trying to cause to error and see what it does. See if you can find an easy way to trigger the error when you're running tests. One third approach to consider when testing something like this is simply to not test it at all. And honestly, that's probably the approach I would take in this case. Now that I've taken the time to show you how to test it, most of the time, if you're running server processes, for example, running inside of a Docker container or on AWS, the current directory never changes. It's set once, and it's the same for literally years. I mean, you maybe restart the process a few times or start a new Docker instance, but you're not changing directories. It just runs in the root of whatever it is. So you don't expect this problem to ever happen. So it's probably not really worth testing it in that case. However, there are types of applications where this could very well be worth testing. If you're building a command line interface, for example, where people run it all the time on their console, and you don't know what directory they're in, and you might actually trigger an error like this, that could very well be worth testing. So it depends on your application and whether or not you think this error is ever possible to occur in the first place, and what are the consequences if it does, to decide whether or not it's worth testing. So, in summary, if you're just trying to get that extra one line of code coverage, this probably isn't worth it. If your application actually does depend on this, and knowing that the error case is handled correctly is really actually important, then it may be worth testing. If you're following a TDD principle, which I like to do a lot, that alone isn't enough reason to test this, in my opinion. This is something that's simple enough to validate. We know the standard library works. It's easy enough to just skip over that test if you choose to, and that would usually be my choice. So there you have it. 3 ways to test something like this. One is mocking, which is probably not a good idea. It's overkill for something like this. It's overcomplicated. The other is to just trigger the error, as I've demonstrated. And the third, and probably the best in this particular case, don't test at all. I hope you've learned something. I hope you'll hit the subscribe button if you're not already to be notified of future videos like this. And if you like these sorts of tips and discussion about Go, you'll love my daily Go newsletter. Go over to boldlygo.tech/daily and you can sign up there, and I'll send you a daily tip on how to use Go better and how to understand the Go language. Until then, boldly go.